And one of the things I learned was that an LLM doesn't have a translation subsystem in the way, say, it does have subsystems for things like coding. So if you say to an LLM, here's some Python, turn it into TypeScript, it does that with subsystems that analyze the logic and break the task down in some quite systematic ways. But translating, say, from French to English, it's just because it knows the same things in French and English and knows how to say them in French and English. Its ability to translate human languages is just a facet of the fact that it's a multilingual language. And that's true with human beings as well. You know, if somebody just said, here is the final year maths book, learn how to do all these things, you wouldn't learn that well. But if you spend years learning all those things and learning how to, being allowed to make mistakes, you develop real skills and real intuitions. And, I don't know what I think about the idea of whether artificial intelligence is like human intelligence, but it has a lot in common with it. But, when I read about GANs, I thought this doesn't make any sense, and it took me, Josh and I worked for a year just making audio GANs and, I got to understand it. But it's very hard in intuitive terms. That's probably the best I could do, that being allowed to make mistakes trains better. And that's true with human beings as well. If somebody just said, here is the final year maths book, learn how to do all these things, you wouldn't learn that well. But if you spend years learning all those things and learning how to, being allowed to make mistakes, you develop real skills and real intuitions.
Welcome to the Ventura Labs podcast. Today, we're joined by Matthew, the founder of Babelbit, Subnet 59. With expertise in linguistic philosophy, computational linguistics, and speech AI, from Cambridge studies to BBC News Online and audio startups, he shares his path to low-latency translation. Matthew discusses LLMs in audio, predictive latency solutions, Bittensor's minor-driven innovation, community support, and linking product value to tokenomics. Now, back to Matthew with the 68th Ventura Labs podcast. All right. Matthew of Babelbit, Subnet 59. How you doing today, man?
Yeah, great. And it's great to be on your Ventura Labs podcast. Yeah, fantastic.
Absolutely. Glad to have you on. And before we recorded, you were going into how the name came about. If you could just continue that story of where Babelbit originated from.
So it has two references which are obviously connected. So there's the story in the Bible about the Tower of Babel. Now, interestingly, that's not really a pro-translation story because it's all about God intervening as people are building this tower to get to heaven, and he makes them all speak different languages so they can't understand each other, so they can't do it. So we're kind of maybe going against God's will by having automatic translation. But in the Hitchhiker's Guide to the Galaxy, there's this notion of the Babel fish, which is this little fish that you put in your ear, and once it's in your ear, you hear everyone speaking your language, and that is the ultimate latency-free automated speech-to-speech translation, and that's what we're going for. So we want to overtake all the competition by being like the Babel fish.
Interesting. Okay, Babel fish. I'll remember that. What is your personal background? Why are you in the speech industry?
So I did a degree in philosophy in the early 90s, and I was quite interested in linguistic philosophy and logic, a lot of stuff that, interestingly, is really coming into its own now with LLMs. So like things like Wittgenstein's theory of language is very different from his predecessors. So I then went on to study computational linguistics at Cambridge, and they had an interesting course because these days it would be a very obvious thing to do speech and language in one course. In those days, though, speech geeks were very much into signal processing and very much in the audio processing camp, and the language people were doing what I guess we'd call more grammatical work, deciding which word is a verb and which is an adjective. Whereas everything has moved towards statistical models. And but that course was fantastic for me because I came out of there having gone in thinking I'd be interested in the language side, but I was far more interested in the speech side because I felt even the language stuff could be done statistically, and most people didn't in those days. But the speech stuff absolutely was a sort of mathematical thing. And the surprise I had when I started was that the big problems had been solved. It was already possible to do accurate real-time speech to text, 95% accurately with a big computer. So I've had a weird career since then. That's what got me interested in it. But then I graduated from there in 95, and there were just loads and loads of jobs in the emerging web industry and not many jobs in speech and language labs. So I went straight into a career building massively scalable systems. Within a couple of years, I joined BBC News and led the launch of BBC News Online, which was very much more heavily automated than anyone else's systems at the time. And I had a real knack for, I guess, building systems where the users just do what they do. So if you're a journalist, you just write. If you're a picture editor, you just edit pictures. And that enabled them to scale massively. So when we launched, we were publishing 300 stories a day with a staff of less than 100, while CNN, who was probably the next biggest competitor, was probably publishing 50 to 70 stories a day with a staff of several hundred. So this was really exciting stuff. And I got very interested in that. But then I started applying my academic work to those kinds of problems. So when I left there, I started, and that's when the real story of Babelfish starts, even though it's 27 years ago or something, 25 years ago at least. The first thing I did was build a system which took in archived audio and video and indexed it, made it searchable using the speech track. So basically you could search the words and every word would have a time code and it would jump to it. And we built systems which you could do things like copy and paste the text and it would edit the video, that sort of stuff. And I got close to Mike Lynch, the founder of Autonomy. And so he then staked me in a startup called Dream Media, which was not to do with Dr. Dre, but it was, we did used to use some of his music at our stands, but it was to do with Autonomy's core engine, which was called the Dynamic Reasoning Engine. And that was, I guess, my first taste of real practical AI. At Cambridge, we'd implemented neural nets to do speech and hidden Markov models and some of these things. And but this was someone who was using, I guess, a less sophisticated technique, but to great practical use. So it was a Bayesian kind of thing. Worked a bit more like, say, Elasticsearch, something like that, where you can compare different blocks of text. And I started introducing speech and video to that. And so Mike and I had an interesting relationship. I didn't stay there that long, but we stayed in touch. And famously, he was killed in a capsized boat last year. And just at that time, the origins of Babelbit were starting. So 5 years ago, this is a long anecdote now. So 5 years ago, I came up with this idea for doing a different kind of sort of trick with speech. It wasn't to do with latency. It was to do with eliminating noise in a novel way. So lots of people had started using GANs to transform images and transform speech. And I thought, well, if you're trying to morph noisy speech into clean speech with a network, you're missing a trick because there'll be a limit to how much you can actually remove. And this is what people were doing. They were training a network to say, here's a bunch of artificially noised speech. Here's the clean speech it came from. And let's map one to the other and see if the network can fill in the gaps and remove the noise. I thought, since my background was in speech recognition, what if the network is recognizing the speech and then resynthesizing it to be completely clean? And Mike didn't really want to invest in designing a new GAN architecture. So I left. And Josh, who I was working with at the time, he stayed, and 3 years later, they tried it my way. There was a limit to how much they could do with the original morphing kind of approach. And 3 years later, there was already another GAN that did something similar. And so they didn't have to design it from scratch and hire a whole load of people. And then they started getting this pristine, clean speech. And they were working on accuracy and latency problems. And this is where the story really starts. Because last August, I was on the phone to Josh, and he explained to me that they'd got the latency down to a level that I thought was never possible. Because I thought you got this process where you're recognizing all the speech, you're also extracting all the features of how you speak, your accent and your tone of voice. And then you've got to resynthesize that without the noise. And I figured that the latency at best would be between a quarter of a second and half a second. So 250 milliseconds I thought was the absolute optimum, the maximum you could do if you optimize the hell out of the network. He got it down to a theoretical minimum of a tenth of that, like 25 milliseconds. And in practice, in their first week of testing this new technique, they got it down to 50 milliseconds. And that is incredible. It's just unbelievable. I'm not a mathematician, and Josh is far better at maths than me. And he explained it to me about 4 times before the penny dropped. And when the penny dropped, I thought, oh, you're guessing what comes next. And that's what led to Babelfish. I thought, well, if you can do that with a signal and just guess the next part of the waveform, what if you can guess the next words? And then I started thinking back to my linguistics lectures and two, I guess, opposing stories kind of from my linguistics lectures, my psycholinguistic lectures struck me. One is that you can't translate some languages as they go along because you have to wait till the end of a clause or the end of a sentence in some cases to understand the sentence at all. So you could have a sentence in German where you don't really know what the sentence is about until you hear the verb, and that's at the end. And there's this famous story that all linguistic students hear, and I have no idea whether it's true. So there's an American journalist in the 20s, or maybe before in the First World War, is listening to Bismarck give a speech, and she's got her interpreter there, and he stops speaking. And she says, what's he saying? What's he saying? And he says, shh, shh, I'm waiting for the verb. So there's this story. This predates machine translation. This is just a problem for interpreters, that you can't understand all German sentences as they go along. You can't create the English equivalent until you've heard the end, because we put the verb quite early. And so that's one story. The other story was, in psycholinguistics, the experiments tell us that a native German speaker, when listening to something like that, they know what the verb is. 99 times out of 100, they already know. So I figured, well, what is an LLM but a predictor for the future words that are coming out of a stream of words? So I figured that if a human being can do it, an LLM can do it. And actually, I remembered there was a Variety Act on this evening TV show. So there's a BBC DJ called Terry Wogan, who's dead now, but he had this evening TV show for years with all kinds of celebrities and sort of crazy variety acts. And one of the acts could speak to whoever was speaking to him and say what they were saying. And basically he was guessing what they were saying and then catching up with them. And it sounded like he was saying whatever you say and as you say it. And he just couldn't be outsmarted. Like whatever Wogan did to try to say something unpredictable, this guy got it. Probably by watching his mouth, by just guessing the sorts of things people do. And I figured, well, if he can do it, an LLM can do it. And then I started thinking, well, that is the way to conquer the latency problem. If we are guessing when we can guess, then we can get huge latency gains. Now, some things you can't guess. If I said, here's a list of all the people I've invited to my party next week, and that's just a random list of people. But sometimes we can guess a long way. So if I start to say, our Father who art in heaven, the next minute, And the interesting thing with translation, it's even easier than the Variety Act guy because you only have to guess the meaning. So if I started this podcast by saying, hi, Grant, thanks for inviting me on your podcast, or I said, hi to Ventura Labs, and welcome to all of your audience. If you translated the wrong one, it wouldn't really matter. It's an opening phrase. We want to move on. And so my idea is that when you can guess confidently, you guess. When it's something that the context tells you is it's not all that important to get it exactly right, you can guess. And sometimes you have to hold back and listen. And the art of this, and what we're starting to develop, is what is that inner process of confidence that tells us when it's right to guess and then you get the latency gain and you move a few words forward, and when is it not right to guess, where you have to be exactly accurate and translate only the words that are spoken. And that is the difficult thing. And that's why, rather than just designing a system with all the state-of-the-art networks that exist, we need months of iterative training that only a process like a Bittensor mining process can really give us. Either you're Google or OpenAI and you put 200 people on it, or you find a way of incentivizing people that you don't have to pay. And that is, so this was a really weird story because I came up with that idea a year, well, I guess 10 months before I even heard of Bittensor. Then I was doing some stuff with LLMs in my job, which is why I was so interested in applying them to language. And my boss was fired. And the company, he agreed with me about innovation. His replacement didn't really. So I left there in March and I started absolutely throwing myself into LLMs. And I was doing it really for coding. You know, I was thinking, well, I've got a lot of ideas. I can't afford a team. I'll just start building stuff with LLMs. And I created a couple of apps, nothing to do with this, but, releasable, high quality software. And I didn't write a single line of code. So I was a real LLM junkie at that stage. So I started posting about it on LinkedIn, and then an old friend, going right back to when I worked with Mike Lynch, a guy called Nigel Grant, who is our main reseller of that speech software and the vision software as well, got in touch and said, hey, you've got to come and join my company, Score. And so this is last week of May this year, and I'd never heard of Bittensor. I joined the company in the first week of June. I was at the Proof of Talk conference in Paris, manning the desk of their stand, trying to pretend to people that I understood what I was talking about. And I met Barry, I met Will from Macrocosmos, I met Mog. And so this was just right in the center of this new thing, trying to get my head around it. Also trying to get my head around Score, because they hired me as head of innovation. So they had a long roadmap of great things. I've known Nigel for 20 something years. I also used to know Tim, his CTO back then when Nigel worked with the company that he worked for. So Tim is great. He's down in Australia, and we didn't get enough time together because of the time zone stuff. So instead of building my innovations on his needs and his roadmap, I was just thinking of great ideas for new subnets, great ideas for new mining challenges, and they were mostly to do with my own pet projects and my speech stuff. And so Max and Nigel said, well, look, instead of, you said that actually Tim doesn't need that much help with this stuff anyway, and he's a long way away. So why don't we help you start your own subnet? And they've just been amazing. So they are now contracted as advisors to Tim, Max, and Nigel, advisors to Babelbit. And it was like this weird thing of two coincidences, that there was this thing that happened with Josh and Mike a year before. I suddenly had the bandwidth and the ability to get machine learning experts working on it without having to get some venture capital and hire a team and all of that stuff. And it all happened in a matter of weeks. And then two other things happened. One, I went and did my desk research, and I thought, well, someone else must have come up with this idea. And that's usually a good thing. I don't sort of think that, it's not like you can patent that idea that easily. And two guys that taught me at Cambridge were working on similar things. So one guy I'd been friends with for a long while because he also had a company that Mike invested in, and we built products together in the early 2000s. That's Tony Robinson, absolutely extraordinary guy. He was the first person to use neural nets for speech that I know of, for large vocabulary connected speech. So in 1987, when he was still a student, he built the first connected speech recognition system. And then by the mid-90s, still very early, he had a neural net system, pure neural net system, that competed very well with the traditional hidden Markov model systems. And it ran in much less memory, much less compute resource. So Tony was doing something on the side of his company, Speechmatics, very interesting, just a project thinking exactly the same. Can LLMs be used for speech? He wasn't specifically thinking about looking ahead in the same way as I was, but he had moved for the first time in his career, really, from speech to language, to thinking about the words rather than thinking about translating sound into text. So another colleague of his that also taught me that I didn't remain friends with. In fact, I don't remember liking him very much. I don't think he liked me very much. A guy called Phil Woodland, very, very eminent Cambridge professor. I guess now probably a very senior professor. He published a paper in April this year. So this is how cutting edge it is. He was building a system which was called Simul S2S, so simultaneous speech to speech. So simultaneous translation just really means real-time translation, that you're translating as you go. And it was called Simul S2S -LLM. And he was basically using LLMs. And then Tony told me about another project, a French one, this company called Qtai, who have a system called Hibiki. And that's probably the closest to our idea that it's like a multimodal LLM can kind of do everything. You can talk to it, it can generate audio, and it can do the translation. And the question is, do you have to even have a multi-stage process? You can actually have an LLM, which is a model that understands audio natively, can generate audio natively, and can translate natively. And that's one of the weirdest things about LLMs. As I was learning more and more about them, I did a little course where you build your own LLM just from the works of Shakespeare and stuff like that, just to understand better how they work. And one of the things I learned was that an LLM doesn't have a translation subsystem in the way, say, it does have subsystems for things like coding. So if you say to an LLM, here's some Python, turn it into TypeScript, it does that with subsystems that analyze the logic and break the task down in some quite systematic ways. But translating, say, from French to English, it's just because it knows the same things in French and English and knows how to say them in French and English. Its ability to translate human languages is just a facet of the fact that it's a multilingual language model, there's no restriction on what language is indexed, so it's all indexed. So it's got whatever that original statistic from OpenAI is, like 40 terabytes of text from the internet. So that fascinated me. And anyway, I started thinking about how to structure this subnet, what our miners would be doing. And then I got another call from Josh. The last call about his work was telling me about this amazing latency gain. And then we were going to actually go for a pint with Mike, but he died on the weekend in between him telling me. So Mike never got to find out that his staff had created this amazing thing. Just like me with my boss being fired, without Mike there was no one in his investment company that was that interested in this innovation and pushing Josh's ideas. So he said, do you know anything interesting that's going on? I said, well, you could come and help me with this. It's something I could do by myself because the miners will do most of the work, but I need to set up the miners with some starting points to work from. So I created the first one, which we're working on now. So the miners at the moment are just doing prediction. So at the moment, we're saying, well, what is the unique thing about our project for speech? It's that we are guessing what's coming next or predicting what's coming next. So I want to prove that is possible. So at the moment, our script and the one that the miners are improving very rapidly is one where the words come in one by one of each utterance of a dialogue. And at every word that comes in, the engine tries to guess the whole utterance. So, and that's quite an interesting task because there comes a point in that cycle. So say there's a sentence of 10 words that maybe 4 words in or 5 words in on average, it's doing quite a good job of guessing the whole thing. So that gives us a measure of how much latency we can save. Now, there's an interesting problem here. Does the script know when it's doing well? At the moment, it doesn't. At the moment, we're just trying to make it good at predicting. The next challenge, which is what Josh is working on now, is going to be a translation challenge. And it's also going to have to work out when to predict and when not. So imagine, probably the easiest way to imagine this is we're going to keep it in text. We're not going to do anything with audio for the moment. Imagine subtitles being generated in real time, like things like YouTube does that pretty well. There are some systems that do it okay. Mostly they're not brilliant. Imagine that coming out in any language, but maybe a second or two later in the other languages. Now, that's going to be our next challenge. So it'll be a genuinely useful piece of tech. It'll be taking streaming words in and putting streaming words out in another language. And the interesting thing is that we'll have to have a first attempt, because the miners will do the rest, of having that confidence quotient, that thing of saying, yeah, I'm really confident in this prediction, or I'm not confident in this prediction, give me another word. And so that's that balance between when to predict and when not, and on a continuous stream where the words just keep coming, is going to be our next challenge. So once Josh has built the prototype for that, we'll then put that out to the miners and say, okay, optimize the hell out of this. And then we'll have our first translation engine, which we will commercialize. And then we'll go back to Josh's work from his previous life when he was dealing exclusively with audio, and start working on the audio in and audio out, and how we can do that. So that's the story, and it's got something for everyone, including the drama of the tragedy of Mike and his daughter. Last year I had to go to their funeral. It was unbelievably horrible. The week before, the same week that Josh called me with this latency gain, and was Mike and I were celebrating. But on the Thursday before he died, we'd been congratulating each other on being great parents, because his daughter Hannah had just got a place to study English at Oxford. As Mike says, Oxford spit, because he's a Cambridge guy. And my son had got a place in Cambridge to study English as well. So we were both kind of bemused. Neither of us was any good at English at school. We're not literary types. Neither of our children was particularly techie. But there you go. And we were just thinking, isn't this wonderful? And then Mike said, yeah, let's go for a pint next Tuesday. And I said, oh, let's get Josh along. He's got something interesting to tell you. And and then his boat sank in the sea. Yeah, just incredibly weird time. But anyway, we've all had to move on. I'm still in touch with his widow. I wondered whether she'd be interested in carrying on sponsoring Josh's work, and maybe I could have got involved in that. But I think that she wants to get away from all of that. So yeah.
Well, sorry to hear about the loss of your friend.
Yeah, no, it was unbelievable. I worked with him on and off for 28 years. It's just an incredibly weird thing. But he was the first person to just take what he'd done from his PhD. The first person I knew, obviously there's plenty in Silicon Valley and elsewhere. He was the first person I knew personally who took something that he did a PhD on and created a commercial product. And autonomy was at one point the highest market cap of any software company in Europe. And obviously had that big scandal when they sold to HP, but he's a harsh businessman, and who knows what to believe in those sorts of situations. But the point was, it was his real ingenious, his own intellectual property that was created, and it fitted right in with mine. So we always got on really well at the tech level, and it's something which the world needs more of, is entrepreneurs who really understand tech. And I guess in America, you have quite a few of them. We don't have very many over here. It's and also we don't have the same venture capital structure here. So even if there are some, they don't tend to. At some point they will sell their company to an American or Japanese company. So take things like ARM. ARM is another Cambridge success story, making, there are more ARM chips than almost anything else in the world. But it's now a Japanese company, And so I think that that's another thing that makes, Bittensor just makes sense to me. I don't need venture capitalists now. I can create a world-class product. And, my model at the moment, there's so many great subnets. And, we were talking earlier about macrocosmos. Subnets are going to be part of our economy here, because we're going to be buying our compute from Shoots, which we already are. We're going to be buying our data from Subnet 13 with their new product. Is it called Gemini? I think is the data product. It's not the subnet name, but they've got a product that sits on Subnet 13, which basically will allow us to say, we want to scrape the dialogue from a bunch of German podcasts, and we need 5 gigabytes of data a week, and it's just self-serve. And this is something which Tony and I and all the other speech researchers we would have killed for like 20 years ago. I mean, back in the day, everyone used the same data set. It was a 75-hour corpus of the same person reading the Wall Street Journal, I think, and that's what everyone used. And they liked the fact that everyone used the same, because it meant if I was comparing my algorithm with your algorithm, that it was a fair comparison. But it wasn't really a good way of training neural nets. It was not unless everyone speaks the same as this guy. So it's just an amazing time. It's not just that our miners come through the Bittensor network, as our suppliers come through it as well. It's just extraordinary. And then meeting people like yourself, where you get to learn that it is a really creative, supportive community where every component in it is trying to support every other component. It really is unbelievable. I mean, I described it to Tony, to just catching up, telling him what I was doing, asking him about his experience of LLMs and how much that had changed his tech. And when he got what I was saying about Bittensor, which I must say, he's very, very sharp. It took him a lot less time than it took me. I think I'd been working for Score for a month before I believed it was true. He was just grinning for the rest of the conversation. We were in a call like this, and he was just grinning, thinking, he was just thinking how many things he could train without having to hire 20 more people. I've never seen him quite so ecstatic about a tech idea. I wish I could say I'd invented it. It was just he was seriously impressed, and it wouldn't surprise me if he forms a subnet for his next project. I think once the cap is taken off, once there are thousands rather than hundreds of subnets, I think that it'll just be the obvious thing for someone like him his brain is like a conveyor belt of great ideas, and if each one of those can go off and be trained, he doesn't have to sort of build a business around each one, then move on. He can just do one, then another, then another. It's just, and you can have a team of miners that switch from one challenge to another. One time they're translating a specific engine for the Mongolian security service, and the next time they're doing something for conversations in the oil industry or whatever. And he does a lot of work with bespoke speech recognition. That's one of the big areas for us as well, is bespoke language models. Can we predict better if we've got a corpus of data which is relevant to the conversations? So say we're selling to people who are using it in the legal industry, then there's all kinds of things there. The way translations work in law is they have to be extremely accurate, but the way conversations go, they have to keep up. You have to, in an argument, in a dialogue, the need for good quality fast translation is huge. But we'd never get it right by training a model on podcasts. But if the legal industry en masse, or if a large company could provide us with material to train on, and we could convince them that we had a secure environment where the confidential information wouldn't leak, then you can see a way of tying this technology into different communities. And I've experienced that in the pure speech tech world as well. We actually another company that Josh and I were involved in, we were doing speaker analysis. So if you've got recordings of speakers, you can tell where the boundaries are, where one speaker stops, the next speaker starts, and characterizing the speakers by whether they've got a different accent or whatever. And we found that our security service in the UK, MI5 as it's called, they had a lot of wiretaps, and they had trained their own model. Actually, they'd paid some consultants to train a version of Caldi, which I wouldn't have chosen because it's a hard one to update. You have to retrain the whole model. Whereas actually, if they'd have used even older technology that Tony developed, you could incrementally add new vocabulary to it and stuff like that. But at the same time, Caldi was free. And they were training it for a language that they call London Asian slang, which is a particular variant of English that mostly young Asian guys speak. I guess women do as well, but I think it was mostly guys. And they had a problem that these guys, when they're speaking, they suddenly change language halfway through. They'll suddenly start speaking a bit of Urdu or speaking a bit of Arabic, and they couldn't detect those boundaries fast enough to switch to the new model. So I did ask why they didn't have all the models running at once, and it would just, but anyway, they probably thought they didn't have the money to do that. But we came up with a very, very quick way of doing that for them. So that thing of where Siri or Google Translate is not going to be good enough because you've got a particular domain of discourse where the predictions, where the vocabulary isn't even known to those systems. So it's an exciting world that we're going into, and yeah, I think I've been talking nonstop. What else do you want to know?
No, yeah, it's an interview, so that's perfect. You've worked directly with MI6 producing speech
MI5
models.
I was more. Well, it wasn't directly. It was through one of the big integrators. So they work with all the big integrators like CGI. That used to be Logica, and Accenture, all those sorts of people. So they all have. They usually have a team that is security cleared. So in autonomy, we had resellers who were security cleared. So even before that, I sold some technology to do something very similar to the NSA, actually. So this was specifically for accents and speaker boundaries. So say they wanted to, so they have, I don't know, 500,000 hours of wiretaps, and they can't listen to all of that. And so this is going back 17, 18 years maybe. So they wanted to be able to do a search, sort of triage on this huge archive. So they might say, okay, I'm looking for a conversation where someone is speaking English with a Birmingham accent or someone speaking English with a Jordanian accent. And even better that they're talking about Semtex or AK-47s or whatever it is they're talking about. And we sold them that. But the interesting thing is, I suspect they never use it. They paid full price for it and they didn't argue. It wasn't the usual government tender. But they invited me to a meeting, and it's the weirdest meeting I've been to. So they weren't sort of black suit type wearing. It was a man and a woman. They looked like kind of 1970s post-grad students, kind of long hair, jeans, T-shirts with band names on, that kind of stuff. And they gave me business cards that they didn't have the organization name and they didn't have their surnames. It was just an email address. It was just Simon and Rebecca, and that was it. No other details. And they must have got me over a period of 2 to 3 hours to whiteboard up every aspect of the algorithm that did this. And my guess is it wasn't just that they were interested, it was because they were going to go build their own. They weren't going to run our code because it might have backdoors in, or it might not meet their needs exactly. So they just so they were happy to pay us, but my guess, they wanted so many details. I thought, well, unless you're building something, why would you need to know all this? But they really wanted to know. So that was fascinating. And I had to fly to one of those places outside DC, in between DC and Langley. Sort of, there's a whole load of little companies that supply those agencies. Yeah, it's but I mean, it's interesting because I got a call once from a UK-based Iranian broadcaster. And they wanted me to create a sort of searchable archive system for Farsi language. And it's a very fragmented language, lots of regional dialects. Even a few villages might speak very differently from the next few. But we had a pretty good solution to it. And they said, nobody makes a Farsi speech recognition system. And what they really meant was Nuance didn't make one and Microsoft didn't make one, because obviously the intelligence services are looking at Farsi and Arabic and all the Middle Eastern languages. So I just thought this was hilarious. They didn't realize that, half the researchers that I know are working on Middle Eastern languages. And I said, don't worry, we can do this for you. And interestingly, we created a great search engine for this news archive, but their lawyers wouldn't let them go in the end because wouldn't let them do it because they weren't using it for their own content. They basically had a hub in the UK which received all the news broadcasts from Iran, from all the different state channels and all the other commercial channels, and they were basically wanted to be able to like having a Reuters wire feed but for video news. And so because they were searching other people's content, their lawyers eventually advised them they weren't allowed to store that stuff, and the spotlight was on them for various reasons. That they're the kind of exiled people, and the Iranian government weren't happy. So it didn't go ahead in the end, but that was pretty cool.
When doing these translations, how difficult is the accents, the slang, the different dialects?
Well, that's something that, I mean, what's what that Josh and I both made it our business to become experts on accents in, I guess, the mid 2010s. So at 2014 to 2019, we were working on a tool for training people to speak in a more intelligible way. Now, that could be getting rid of their accent or softening their accent, making it more understandable. And it is very difficult, but because accents are systematic, it's really, the difficulty is a function of how much data you have. So whether it's an accent, whether it's a speech impediment, like a lisp or something like that, they're very easy to do because they're systematic. So it just comes out in the data that someone with a lisp says speaker, or whatever. And I used to do this demo of our software because it was unlike the other educational software at the time. It was on continuous speech. So you just read, and you can read your favorite book. You could read your own conference speech. So say you're giving a speech in London, you're worried about your English accent, and it will tell you what you're doing wrong. So I used to just imitate certain very specific problems. Like one really common problem across lots of different languages is they can't say a short I because it doesn't exist in the language. So it's something like hit comes as heat, and then making a voiced th like the, a z, a z replacing the th. So I would speak like this, and I'd show that for the demo. It would then highlight the sounds I was getting wrong, and then I'd speak normally, and the score would change back to the right score for the accent. And actually, that was pretty easy once you understand the guts of how speech recognition works, because it's already breaking things down into the sound. And if the accent is effectively morphing specific sounds, it's fine. There's other ones which are kind of clustered together because the mouth is in a different position, the tongue's in a different position across a whole language. So then, but we still kept it to these kind of more or less what's called a substitution error, that instead of making sound A, you make sound B. And so now we don't have to do that because the models are big enough to take care of it all. And that, when Siri first came out, they had 7 versions of English. Just for English, they had 7 different models. And oddly enough, I think you couldn't change it on your iPhone. So it was kind of, it wasn't one of the settings. So if you bought an iPhone in India, it would expect you to speak Indian English with a strong Indian accent. And they did a great job, but they still, because there are only 7 and there are dozens or hundreds of English accents, they got a lot of, a lot of people made fun of them. So you'd get these YouTube clips of someone with a heavy Scottish accent talking to Siri and making mistakes. And they solved that really quickly, because at that time, I was thinking, oh, this is great for us. We could sell them the engine, which would make we could dynamically send the speaker to the right model for their accents, But they created hybrid models that could do multiple accents, really soon after, and really everything changed in the mid 2010s. With the sort of emergence of deep learning for audio and for speech and language. That really changed everything. And then for language, it changed again with transformers and LLMs. So, just in my career, I've seen, these massive paradigm shifts. And I actually, I created a little graphic. I think I can probably share screen and share it to you, because it was slightly humorous. It wasn't entirely supposed to be serious, but it shows how things have converged. Where have I got it somewhere? Yeah, here we go. Let's have a look. Oh, this is the wrong one. Typical. Hold on, I've got it on a web page. Sorry, you can edit out the gaps, I guess.
We'll leave it in. It's all good.
Yeah.
And then, is it reasonable to expect Babelbit to have one model that covers all languages, all accents?
That's a very interesting question. My guess is no, but not for the reason you think. Because the language models certainly have all languages in, but there'll be some languages which are a real minority and have less data. So in the same way that ChatGPT or Grok is much better at coding in Python than it is in Elixir because there's more Python code for it to learn from. So that's one problem. But the other is that the confidence part will be intrinsically less confident in languages with rigid word order that pushes the meaning towards the end of the sentence. So that's an interesting one. And whether it has to know what language it's dealing with to make the right adjustments, I don't yet know. I think that will have to come out of the minor's job, because we'll set them challenges to do German to English and English to German, and maybe they're not the same. Maybe if they can get way better performance by having a special German to English version, it might be the way to go. But my guess is that it would normalize over time anyway, because we will ultimately be building bespoke LLMs. We won't be building on top of DeepSeek or Olama or Mistral. We'll be building our own because actually there's a lot of stuff in LLMs we don't need. We don't need to be an encyclopedia. We need to be a dictionary. So but anyway, here's my little. As I say, it's not supposed to be 100% academically correct, but this is because I've been in this game since the 90s. I came in, around about here, the mid 90s, and everything in speech recognition, the good systems were HMMs, are the very earliest neural net systems, which Tony was developing. Synthesis, the straight vocoder was a big deal at the time, and then translation was done by a bunch of different technologies, and I didn't really have much to do with translation then. I did have some lectures on it, but it wasn't the thing that sort of grabbed my imagination. And as you move into the 2000s, you get deep learning, and you get these hybrid systems which still use a lot of the HMM based stuff. Don't see much of that anymore. And there's a bit more convergence, that you're using RNNs for language and RNNs for recognition. And then the last 10 years, it's been crazy, but still very fragmented. So if you look at how, I don't know if you ever saw the demo that Google did of WaveNet in 2017 when it came out.
I did not catch that demo. No.
It was just incredible. It changed everything for everyone in the speech world and in other audio world. So they had this system called Tachytron, which is their text-to-speech system, and they added WaveNet to it, which is a neural net vocoder that made it sound like a human being. And it was the first speech synthesis that really sounded human. But just the synthesis part was 2 stages. Now we're talking about doing recognition, translation, and synthesis in 1 stage, and that's what Hibiki does and what other projects are doing. So that's the final. That's why this is like the punchline on the right here. That we can do speech recognition with an LLM. I can talk to ChatGPT and say, please display what I've said, and it will do it. I can translate. So I had a foreign language letter, which in a language I didn't even recognize. I tried using Google Translate on it, and the handwriting wasn't legible, whatever. ChatGPT did a great job of it. That's translating handwriting, a different kind of input, and did a perfect text output. And then synthesis. It does a great job of that too. So as we move to true multimodal technology, I'm not saying that the synthesis on the ChatGPT app is integral to the LLM. It's almost certainly a separate subsystem, but that's where we're all headed. We're all headed to a world where the model doesn't just understand everything about everything. It also understands it in any mode. It understands language as speech, not understands language once it's been translated from or transcribed from speech. And that's what we're so excited about. And when I showed this to Josh and said, "Is this accurate, you think?" And I said, I'm kind of joking about LLMs. He said, "Well, not really. We really are moving in that direction. That's where it's going." And that it, I think, quite rightly so. This is how the brain works. And it's very exciting. To as a technologist to still be in the game, having been through all of these things. And if you think about building a system like this, even 5 years ago, you'd have to get those 7 or 8 different technologies all to work harmoniously together. And actually, that's one of Josh's main bits of expertise, is collapsing multi-stage processes into a single stage. And that's exactly what we've tasked him with. So as we move to prediction and then translation in a single shot, we'll be doing audio input into translation as a single shot, and then audio and audio out. And that, he describes it as a kind of conveyor belt type system, that 1 bit of audio comes in this end and 1 bit of audio goes out the other end, or 1 samp, one, if you imagine a waveform, it's made up of all the integers that say how big the wave is at any point. Each of those integers comes out like every, 16,000 of them a second. And this is why WaveNet was so amazing. WaveNet is literally predicting the next samp by samp. It's not saying, you can do WaveNet, you can use it for music as well as speech. So you could say, if you got the right engine behind it, you can say improvise piano in the style of Chopin, and it will do it. And it's not doing what you think. It's not saying, do I need a C next because this is in G, or do I need a D, or do I need a C sharp? It's not thinking like that at all. It's literally thinking which integer comes next. And that's the weird thing about generative AI, is that it works like I speak. I don't know what's coming next. It just keeps coming out. I'm not a German. I don't plan the whole sentence ahead of time. So I think that the big problem that means that I can't have a startup like my Accent startup a few years ago with 4 guys, is that these models are gigantic and they need training. I can't afford to compete with OpenAI just with 4 guys in a room. And that's what startups used to be able to do, because it was all about having the clever idea. But neural nets are so unwieldy and so unpredictable that you have to have that training effort. So when I first started learning about GANs, I thought they were really weird and spooky because of the language people used about them. It's like, if you're a software engineer, you have an idea, you write the code and it works, or it's buggy and 2 days later it works, But you'd get people who just developed a neural net to do something really useful, might be for medical imaging or something like that. And they'd say, oh yeah, I was training this GAN yesterday, but it collapsed. You think, okay, well, why didn't you know it was going to collapse? Because the data is part of the logic with a neural network. And when you see a neural network do something interesting, like you've probably seen those ones where it morphs an image of a modern street, and then it changes all the tarmac to cobbles, and all the windows to and the roofs and everything changes to look like an old street. Now that is kind of a weird sort of process. And when you see it happen, you think, oh, I'd love to be able to see inside the neural net, because you imagine that what the neural net has done is kind of, by iteratively training the data, it's invented an algorithm to do that thing. But it's not really like that. You can't really look inside. I did see that there are some projects. There's an Italian team who were building a kind of visualizer to see what goes on in neural nets. But it's that kind of instinct. It doesn't pay off, because even if it's not something you can replicate. You can't say, oh, let's take a shortcut, and instead of training it for months, let's just work out what it should be doing and just prescribe it. The training is part of it. And that's why GANs are so weird. So GANs have 2 networks which train each other. So the archetypal one they tell you about when you learn about this is generating photorealistic human images. And you start with an image creator, which is no better than drawing stickmen. And then you have a discriminator that can hardly tell a stickman from a photograph. And they learn together. They get better and better together. And I thought, well, why can't you start with an excellent discriminator, and that will just train the generator? So you're generating images, the discriminator says good or bad, and you train better. But what happens if you do that is that they end up doing things like just creating the same image over and over again. They don't end up with the breadth of experience and knowledge. And that's kind of what's happening in this training. And I thought, well, how can that be true? Why can't an expert discriminator help training? And it's something to do with being allowed to make mistakes, because sometimes it'll generate a synthetic image which the discriminator thinks of as a real image, and it'll give false feedback to the network. And then they'll go off in the wrong direction, try lots of other things. So it'll end up trying lots more different stuff out and getting far more skilled at generating images by sometimes being allowed to get it wrong, which an excellent pre-trained discriminator wouldn't do. But, when I read about GANs, I thought, this doesn't make any sense, and it took me, Josh and I worked for a year just making audio GANs, and, I got to understand it. But it's very hard in kind of, in intuitive terms, that's probably the best I could do, that being allowed to make mistakes trains better. And that's true with human beings as well. If somebody just said, here is the final year maths book, learn how to do all these things. You wouldn't learn that well. But if you spend years learning all those things and learning how to, being allowed to make mistakes, you develop real skills and real intuitions. And, I don't know what I think about the idea of whether artificial intelligence is like human intelligence, but it has a lot in common with it. Even if it's, I don't get in those philosophical arguments. I was a philosophy student, and I find most people who do don't know what the hell they're talking about anyway. So I tend to stay in the world of building stuff, making practical steps and trying to make new things. Yeah. And that's the fun part, of course. Yeah.
In Babelbit, how do you balance allowing the miners to have that ability to make mistakes?
That's an interesting one, because obviously at that stage, I suppose, is it the miners that make the mistakes or the network? Yeah, I suppose it's that miners do that anyway. So miners will find any way they can to win. So either they have some great intuition because they're experienced, or they just try loads of different things until the scores come out higher. So in our repo, we bundle the test scripts, so you can try it out as much as you want. You can get to understand how our validators will be scoring you. And then when you make your submission, hopefully that's based on quite a bit of experience, but there's nothing to stop you submitting, every day. We're going to have more at the moment that we're doing about one challenge a day. We've got I think there are about 20 miners on this morning. When it gets into the hundreds, I guess we'll probably do one an hour. But it's interesting. That's one I must talk to the other people that are doing the same kind of networks, because obviously there are all sorts of networks for things like storage, compute, and whatever. But I see that Score they've now moved to an iterative network to improve their process. Their old network used to actually do work for customers. So the incentive mechanism was divided between everyone that did some work, and you did more work, you got more money. They're now moving to a winner takes all approach as well. And we forked their repo. We didn't write it from scratch, so that's how we got live in 2 weeks from a standing start. And then the other one that I've been talking a lot to is Shaq from Ridges, and he's also got this iterative process. So I think we should definitely start comparing notes on what is the mixture of ingenuity in those iterations from the miners and pure optimization. So some people will just take a bunch of code and say, I know how to make this run better, run faster, whatever. Other people will say, actually, I know how to make it run differently, and the results will be better. And actually, well, the first time I met Shaq, I was talking about my experience of using LLMs to generate code, and he said, oh, well, if you've solved some of those problems, you should mine for us and you can earn some money. So that might be something I do, is spend my weekends being a Ridges miner. But,
What do you view the end goal of Babelbit as? Is it develop your own consumer product? Is it just feed an API to others?
I think an API is easier. I mean, I've worked in consumer products a lot. So major things like, obviously things like the BBC News website, but I developed ITV's catch-up TV service, stuff like that, and those were all building on big brands. I also did one spin-off of the Open University, which was a new brand called FutureLearn, and it's tough. Whereas an API, if you can prove that your results are better or your results are the same and it's cheaper, then the sales and marketing, the branding is less important. It's less of a gamble. So I think even if we did develop consumer products, we would definitely develop APIs first, because one lesson I really got from autonomy was that if you create fundamental technologies, you can sell through expert resellers and expert OEM partners who bundle your tech into their products in any sector you like, because you don't have to be an expert in children's products or in consumer products or in business products. You can be, or in legal products versus oil industry products. So I think that's the main reason, is that you can get to the whole world if you're just selling the pure tech. So I think that's it'd be to replace those API based products like that Google and AWS and Microsoft have, with just lower latency, more accurate translation. There's another idea I had about the productization, which I think would work very well for this kind of context. So obviously this is going to be a recorded podcast, but say this was live, and you want an audience of multiple languages, that you would set the parameters so that it's a little bit more generous on errors while we're talking, so people can keep up with what we're saying. But then you have a parallel process which is optimized for accuracy, which then gives you a written transcript in your language of the whole thing, which is super accurate. So you can't wait while you're listening. You don't want to be waiting all the time. So you can relax on the accuracy there. And I think that's going to be one of the most interesting things as we develop this kind of what I referred to before, this confidence quotient, is this internal measure of how well is the network doing in terms of its predictions. That will be the thing that changes. You can say, okay, well, in this context, start translating when you're only 30% confident. In this other context, translate only when you're 90% confident. And that's a really interesting balance, and that'll be definitely an art of how the API works. Because different, if you put that in the hands of the users or the implementers, they can play with that to their heart's content. And that's absolutely the way I see it going. But at the same time, Apple made a big deal of their translating AirPods, and I kind of feel like, if in a year's time they're using Babelbit and they rebrand their AirPods as Airfish or as Babelbit Pods, or I don't know. Yeah, they'll put an I in front of it, an I Babel. Yeah, yeah.
I Babel. I see it. Well,
Yeah.
Matthew, I got one last question for you here today.
Yeah.
And that is, since you are a specialist in linguistics and speech, what advice would you have for other specialists when trying to take advantage of Bittensor? How can they utilize Bittensor to further their specialty?
Well, I mean, I got incredibly lucky working with Max and Nigel and Tim, because they'd done it from scratch. They'd come in and they got a lot of help from other people as well, but nowhere near as much as they helped me. And, I had help from Yuma and others. But so the advice I would give is, one, get into the community. It's an unbelievably friendly community. When Tim was working with Tim, he's in Australia. It's very hard to find time to meet. So I would ask questions of Steph at Microcosmos, and he gave us so much of his time with no, obviously, hopefully he'll make a big sale and we'll be buying data from him forevermore. But at the same time, he really, let us explain our problems in detail, gave us all kinds of advice, helped us with testnet getting up and running, and it's an incredible community. It really is. The people I met in Paris were all happy to follow up with me, even though I was a complete newbie. There's no kind of, I mean, I'm notorious for not getting embarrassed. I'll say, I don't mind looking like an idiot, because half the time, you've got to, if you're constantly innovating, you're always going to be a newbie in something, so that's the other thing, is just don't be embarrassed. We're all making it up as we go along, because it's a new field. And actually, when at the beginning of this year, detail didn't exist, so, the idea, now everyone is worried about the tokenomics of their specific alpha. And, a year ago that didn't even exist, in another year, who knows what it will be like. And maybe, I worry about all kinds of things, as everyone does. If, for instance, there was no cap, anyone could form a subnet and it's a pure free market if anyone wants to join in. Would that be good or would it be bad? I mean, one way it would be good would be, I've got 5 other ideas. I could put a subnet out for all of them and see which one does best. That sounds like a good idea. Another one would be, what happens when the public eye, casts its spotlight on Babelbit or on Bittensor rather. Say there was a huge article about the economics of Bittensor in the Financial Times or the Wall Street Journal. Would that be good or would it be bad? Would it mean that Elon Musk would say, hey, I could lower my costs. I'm going to create a subnet and I'm going to pay everyone 100 times and kill all the others? Or would he just buy all the others? Or would he set up, Grok Tensor and just say Grok Tensor is better than Bittensor, so I kind of feel like the only thing to do with almost all aspects of AI is just get involved. And, I got into this position because I started talking about all the fun I was having with LLMs, and Nigel reached out to me. To be honest, you don't have to have mates that will reach out to you. People are really approachable, and it was apparent in Paris, it's apparent, online. I've never encountered anything like that. There's this weird thing that mostly the subnets aren't competing with each other. So that's a weird thing, isn't it? Because it's like mostly in the startup world, if you're all speech people, you might think, well, I don't want to tell you too much about my problems with my algorithm because I might give something away that will help you with your one. But, Steph and Will are doing these incredible things with, one of the most amazing things they're doing is this distributed training of a single network. It's mind-blowingly complex. And they are ahead of anyone on that, not just within Bittensor, but no one in Bittensor is competing with that. So they're happy to give advice. I think that's the advice I would give. The other thing is something I didn't do. Think about how the value your product creates can be linked to your subnet's value. So we're all trying to make our subnets more valuable to have a bigger share of the staked money. So my original thought was this is miners are going to replace having a gigantic staff, and it'll be much cheaper to run my company because of that. But what they'll be creating will be software, which I can sell in the usual way. So there's basically, two main ways to do it. One is on premises or on device that I sell you the software and you run it on your network or whatever, or I have it as a SaaS product in the cloud. And how does that benefit my alpha? How does that benefit an investor on the Bittensor side? So now I've been thinking, well, actually, all my ideas about how prediction can be made more accurate by having customer-specific or sector-specific data sets means I could do some kind of link there. That if you're willing to pay us to host your data to make the models better for you, then that can be something which we could charge for as a kind of stake. That while we're doing that, you're staking with us, and if you want to carry on, that's fine. I was trying to come up with our equivalent of what Hippias are doing with storage. That there's kind of, they're doing it with a separate token even, but that idea was really ingenious. And I wrote a paper with about 5 different tokenomics ideas of how I can link the software sales to the product, and I think that I've been circulating that with people that know more than I do. And I had a great meeting with Mog last week, and he was so passionate about that aspect of it. And I think that that's another bit of advice I would give. If you can go into it with an idea where the value created by the product intrinsically can be linked to supporting the value of your alpha, then that will make it a more exciting investment opportunity for people who are staking. So we're absolutely, intent on doing that. And I think at the moment, the best way, some people are doing it where they literally have miners who are working for a customer. So they split their incentive between different customers. The miners do work specifically for customers, and they have some kind of link in that way. That's another thing we could do. But I didn't really think about that in advance. I don't think people were even thinking about that much 6 months ago. So it's kind of interesting the way the culture has changed a bit towards this linkage of product revenue and product distribution against staking Tau. Yeah.
It is true. Bittensor moves very fast. And I would like to echo your point of everyone is very approachable.
Yeah,
in Bittensor. You'd be surprised. Well, Matthew, it's been a pleasure having you on today. Thank you.
Likewise. Thank you very much. And I'll see you around. See you on Discord.